The derivatives of logarithms and exponential functions. The derivative of log of x is equal to 1 over x. The derivative of base b log of x is equal to 1 over x natural log b. The derivative of log of u, if u is a function of x, is 1 over u times du dx. The derivative of base b log of u is 1 over u times natural log b times du dx. So again, we want to find the derivative here of the natural log of x squared plus 5. Our outside function is the log function. The inside function is the x squared plus 5. So as we always do with the chain rule, we take the derivative of the outsidemost function. The derivative log of something is 1 over that something. So 1 over x squared plus 5 times the derivative of the inside. So the derivative of x squared plus 5. That derivative is 2x. And so you end up with your final answer, 1 over x squared plus 5 times 2x. In this example, we want to find the derivative of the log of the square root of x squared plus 1. Our outsidemost function is the log function. So the derivative here should be 1 over the inside function, the root of x plus 1, times the derivative of the inside function, which is the root of x plus 1. Now, when we differentiate the root of x plus 1, we notice that this is really x plus 1 to the 1/2 that we want to differentiate. So we have another composite function. That derivative is going to be 1/2 x plus 1 to the negative 1/2 times the derivative of the inside x plus 1. And since that derivative is 1, we end up with 1 over the root of x plus 1 times 1/2 times x plus 1 to the negative 1/2. If we want to take the derivative of an exponential function, we'll find that the derivative of v to the x is equal to e to the x. The derivative of a to the x is a to the x times natural log of a. The derivative of e to the u is e to the u times du dx if u is a function of x. And the derivative of a to the u is a to the u times natural log a times du dx. Here we want to compute the derivative of e to the x squared plus x minus 5. Again, we see that this is a composite function where e to some power is the outsidemost function, and x squared plus x minus 5 is the insidemost function. So the derivative of e to the x squared plus x minus 5 is equal to e to the x squared plus x minus 5 times the derivative of the inside. The derivative of the inside is 2x plus 1. So our final answer is e to the x squared plus x minus 5 times 2x plus 1. Here we want to find the derivative of e to the 2x minus 1 plus 3 to the x divided by x. Because this is the sum, we can deal with each summed individually. So the derivative here is the derivative of e to the 2x plus 1 plus the derivative of 3 to the x divided by x. First derivative, the derivative of e to the 2x plus 1, is a chain rule. So we want to take the derivative of e to the something, which is e to the something, times the derivative of the inside. Our second term is a quotient of two functions. So we want to use the quotient rule. So our second derivative is going to be u prime times v minus v prime times u divided by v squared, where u is 3 to the x and v is x. So what we get is 2e to the 2x minus 1 plus 3 to the x natural log 3 times x minus 1 times 3 to the x divided by x squared. If we factor out the 3 to the x, we can simplify this a little bit to 2 times e to the 2x minus 1 plus 3 to the x times natural log 3 times x minus 1 divided by x squared. In the early stages of the AIDS epidemic during the 1980s, the number of cases in the United States was increasing by about 50% every 6 months. By the start of 1983, there were approximately 1,600 AIDS cases in the United States. Had this trend continued, how many new cases per year would have been occurring by the start of 1993? The exponential model used here, beginning at 1983, is a equals a times b to the t, where little a is 1,600, b is 1.5 times 1.5, or 2.25, and t is in years since 1983. So a is equal to 1,600 times 2.25 t. If we differentiate this, a prime of t is 1,600 times 2.25 to the power of t times log of 2.25. So in 1993, 10 years later, we would expect a prime of t to be equal to 1,600 times 2.25 to the 10 times log of 2.25, or about 4.3 million new cases per year.